Okay, Western Iowa Tech today in our Motorcycle Power Sports Technology program, we're continuing on with our electrical testing. First off, we did a static bench test, if you will, of the Stator, and now we've got a different bike here where we're actually going to measure the AC output. You guys, we've been talking about this alternator generator down here that's going to have a rotor that spins around to produce AC voltage before it goes back into a regulator rectifier, changes it to DC, and then charges the battery. So Keith and I are going to do this right now. It might get a little noisy. Before we fire it up, there's a couple things. Without looking at our service manual, what did I call that I said was a concern of all power sports engines? What do we have to run that up past? Break-even voltage, okay? So what we're going to do is we're going to check it at idle. We're going to see what we get for AC voltage. Matter of fact, Woogie, you've got another meter. You can take and put your meter on the battery on DC volts, and then we'll perform two tests. We're going to actually be able to see what the battery is. We're not going to be able to see what's being put into it, but we're just going to watch the health of his battery, at least at this point. We will re-hook this up and do a charging system output test as well. On this one here, we want to have our leads in the right place. We are testing volts, okay? We're testing volts here, so we're in the right position. We are calm. Now I need to go to AC, and this little cheap meter, I can only go down to 200 volts AC. We know that this is anywhere from 30 to 100 volts AC, so we're going to be good. You could start on the 750 scale. It's just going to be a little bit harder to read. Keith, you hold that. Go ahead and fire your bike up. And what we should see is the AC voltage can change with RPM being revved up. So I'm simply going to go here. Okay, look, at idle I'm getting 17 volts. Now go ahead and rev it up to 1,000. Or, sorry, 2,000. You go to 2,000. Notice how we're going up. Okay, let it drop down. Now, go ahead and kill it for a second. Now, one thing we got to be careful of, we don't want to take a bike that's, completely bone cold and then sit and run it to 19,000 RPM or something, okay? So since this isn't fully warmed up, you guys saw that at idle at about, what's this, 1,100? Yeah. About 1,100 RPM, this thing actually idled, or it was putting out, 17 volts AC. We barely pumped it up, 900 RPM, what it jumped to? 22, 24. It hit 30. We saw 30, 31, so it was really getting up there. If we went another 1,000, got up to 3,000, what do you think we're going to get up to? Okay, well, let's find out. We'll run it to 3,000. That's not bad for a fast idle on a bike that does 11,000 RPM. Now, what you're going to see me do is you're going to see me, I only tested how many legs of the three-phase coil right now? Two. One. I've only really tested one. I have to move it 2 more times to test all 3. I am going to do this. We're going to get this to 3,000 RPM. We're going to hold it. We're going to steady it. I'm going to switch them around, test all 3 coils, and what should I actually see? What do I want consistent? Voltage. The AC voltage that's going to come out of those. Let's do it. We hit 60. Can you make it happen? Consistent. I'm going to move another time. Consistent. Everything's good, right? Okay. Well, we're happy. We saw 60 volts and we really didn't get that high. What does that tell you about this bike? Do you believe it has a break-even voltage? Do you believe that without a service manual, it's going to tell us that we are going to have to rev this to a certain RPM to actually see what happens, and we're going to see it increase accordingly? Now, do you get how this is such a better test than just the continuity test that we did earlier? Let's take this one step further. Keith, I'll let you hook your bike back up. Did you dielectric grease it yet?
Not yet.
We'll take it back apart and do that. We're just really in a testing phase. Now the bike's back to stock right now, correct? Wouldn't we come around and do a DC voltage across the battery? We're going to start off and just check our battery voltage. 12.6. Okay, fire up the bike. I'm going to hold your meter if you don't mind. Look, at idle, 14.5 volts, pretty good charging system. Pay attention. Remember, it only put out 17 volts at idle AC. Pretty good charging system. Let's go ahead and rev it up and make sure we... Now, why do we need to rev it up, guys? You tell me. Make sure it's not overcharging it. You're correct, Casey. Go ahead, let's do it. Regulator's doing its job. Go ahead and shut off. Let's think about everything we learned so far here. Okay, so we do the continuity test. We're just verifying that we don't have shorts to ground. That's all we're doing. When we do the AC or the dynamic output test, what are we verifying? Consistency of that output between those coils, all right? But I want you to think about the regulator's job for a second here. Would you guys all agree with me? 17 volts at idle. At 3,000 RPM, we were seeing anywhere from 45 to 60 volts. It was kind of hard to hold that steady throttle. 60 volts AC, right? Okay, now when you tested the actual battery's charging system, though, how many were surprised that it didn't actually, at idle, this was producing what? 14.5. Okay, when we revved it up, what did it do? We saw 14, 14.5, kind of bounced around a little bit. Weren't you guys maybe expecting it to see it creep up on 15? This regulator is really doing its job. You saw this go from 17 to 60, but you didn't see the maximum output, change that much. Now, I'll tell you this, if he was riding down the road and he switched to high beam and he had some driving lights and he had a heated vest on and everything else, that charging system's really going to have to work to keep up. We might see it, float up there a little bit more. Does that make sense? Okay, this is how you accurately test the whole system. As far as thinking about failures, if I had continuity to ground or not between the coils, stator's bad, right? If I don't produce a consistent AC voltage, it's more than likely the stator's bad. Now, we're doing this all without a service manual. If I go to the service manual and it tells me that I need, let's say I'm not charging the battery. Let's say I'm only getting battery voltage here. If I do an AC test and it tells me at 3,000 RPM I need 60 volts AC and I only have 15, do I have a problem? The coil's shorted internally, that's the problem. If I have good AC output, good bench test, and my battery's still not charging, and my battery's good, the battery's been load testing, my connectors are good, my fuse is good, my wire, everything's good. What's the only part left that can be wrong? The regulator rectifier, okay? Last test to think about is we actually revved it up purposely to make sure that it was dumping the voltage. If I was allowing more than 14.5 or 15 volts, especially if I get over 15 volts, what do I know is the problem? Regulator rectifier. It's the only thing. Overcharging can't be accomplished because of the stator. Overcharging isn't because of the wires. It's simply because that regulator's not doing its job. Other than the fact that if we had a bad ground on the regulator, not allowing it to dump, we've got a problem going on there. Anyway, that's everything we've got going on so far for your three-phase permanent magnet charging system.